this. All right, let's go with homework reply to your replies here. Some person, won't name names here, said we were not asked if we were turning things online. Yes, I did check homework inside the class, but I figured, why am I doing it twice? I'm checking homework in class, then I'm checking it online as well. So I figured we'll just make a schedule, like 5.4 is due today on the schedule, and I will update it. I'm thinking, why do I go home and then think I'm gonna update it later? So if any updates are gonna happen, it's gonna happen right before I go home. I'll stay here, update all the due dates for the homework, and then I'll check it out so it's always current when I leave here for the day. So 5.4 is due today. So let's go with any homework questions from 5.4, and then we'll go through any homework questions 5.5 on Wednesday. As far as I'll get to you just a second with eyes here. Here's a schedule that I have. If this makes sense to you guys here, we'll leave it. So are we good there? So I'm thinking we'll probably finish up 5.5 today. Not exam, that's not fun. If anything, maybe finish up 5.5. We have also the challenge problems to sort of talk about. I'll do those, and then homework 5.5 due, and then Friday we come back to like a review on anything that you guys have, and test a week from today. Are we good? Boom. Okay. So let's do this here. I'll wait for challenge problem for Wednesday's class. I just want to make sure if we have time today, we'll go over it here. So where are you looking at the schedule here? Go for it. If whoever was writing down the schedule for their own schedule. Jamming, let's go with it here. Any homework questions for 5.4? Yes, no, or maybe?
I think I understood 21. I mean, we got the right answer, but can we just, I'm still, I think, a little bit confused on like the whole ratio thing and when it's flipped and when it's not flipped. So 21.
21. Sure.
Also, Amanda and I were doing homework together, and sometimes we got confused on like positive and negative.
Yeah.
Like,
yeah.
And so, yeah, can we just like go over that concept more?
Sure. Anyone in particular though?
I have a similar thing for
Yeah.
35.
35.
Can we get it to go over it?
This is 5.4, right? 5.4?
Yeah.
Now the graphing.
We're like, wait, why is this negative?
Yeah. Wait, we didn't do 35.
Wait, did we do 35?
Do we have to do 35?
Yeah, it was 1 through 41, wasn't it?
Every other.
Yeah. So
9, 5,
I did all the odd ones.
17, 21, 25, 29, 33.
Yeah, 33, 37.
33 and 37, I both had.
Wait, Grant, did you do all the odds?
Yeah.
Oh.
Was it every other
Every
odd?
other
Every
odd.
other odd.
Oh, I thought it was every other one.
Okay, Grant,
Gotcha.
you need to explain to us how to do the problem because you are now the resident master.
Well, no, 35 and 37 are pretty much the same, so switch.
Yeah,
one
that's
to
true.
37.
Okay. All right, let's jam with it here. So 21 it is, looking at this one here, but you guys talked about the negative positive issue as well, as I'm thinking about it. So you just have to decide which way you want to go.
Much for every homework.
You are super ready for this exam.
I'm like, why are these so long?
Yeah, I was thinking that. I was like,
That's a lot.
what is going on? It's like
I'm
2
sorry.
or 4 different.
For the positive and negative issue here, let's do 17, and maybe that will clear up a few things here. So I have, nope, that will not. 17 won't help because it's the same thing here. Oh no, maybe we'll here. Sine of trying to find sine b over 2. Am I recording? And we have, it is negative 1/3, and we are in quadrant 3. So we have to think to ourselves here, if I'm in quadrant 3, if I take half of that, I will be in quadrant, I believe it's 2, is that right? I'm going from 180 to 70, sort of like the range of 180 to 270. I'm cutting that in half. And that puts me at 90 degrees from the 180, cutting that in half. This puts me at 135, which is the middle of quadrant 2. So in this case, the formula that I want to use is going to be the positive formula. Are we good for the half angle? Because sine is going to be positive in quadrant 2. We're taking that angle, we're cutting it in half. All right, talk to me here. I know it's Monday morning. I know it's an hour earlier than we normally would have class. I already zoned out, but are we okay with that?
So even though the original one is in quadrant 3 and negative, because it's in quadrant 2, it's positive.
Yeah, the finalized angle that you're looking for is in quadrant 2. So always look at your final angle. So plus, and then here is 1 minus cosine of A over 2, or in this case, cosine of B over 2. And that's another problem, because then the formula calls for a cosine value, not a sine value. So then we go back over here, go back to angle B, which is somewhere inside quadrant 3. And then all I know is, I know this guy is the y value. So I have a y value being -1. I have a r value that's being 3, and I don't know what x is yet, but I need it for cosine. So x squared plus a -1 squared is equal to 3 squared. 1, 9, I assume 8. And the square root of 8 is 2 root 2. Are we good there with that? Cool. Now let's plug it in. So we got our angle the way we want it here. Let's see. That's x, so that means cosine would have to be 1 minus cosine of b is 2 root 2 over 3. Negative, is that right? Okay, we're good there, at least for the starters of it. So negative is a positive, subtracting a negative, same thing as adding. And then I'm going to get common denominators here already. Putting the top together, 3 minus 2 root 2 over 3. And then I can change this to a multiplication. So I'm going to multiply by 1/2 already. And that should give me 3 minus 2 root 2 over 6. Is that right? Thank you. Should be a plus sign. There and there. What did you get again?
Yeah, I had minus.
Oh, hold on. Da-da-da.
Why would the 2 root 2 over 3 be negative?
Let's see. Let's go over here. So this little guy right here, we have a choice of plus or minus right over here. For this one, as we took square root of 8, which is 4 times 2. 2 is going on the outside. And because we are in quadrant, we're in quadrant 3 still, we have that answer. Oh, sorry, this answer here, the negative 2 root 2. I'm just checking here, make sure my formula is correct real quick here. The sine value is 1 minus cosine. So that becomes a little minus sign. You guys talk to me here. Does that make sense there so far?
Oh, yeah.
Right, because you're subtracting a negative there. Plus, we've got a square root of 6 on here. That's not a perfect square. And so Let's see. Out of curiosity here, let's see if they rationalize everything here. Why they leave it 6 in there? 21. Okay. Wow. It was 17, right? 17? Yeah, they leave the 6 there. Okay. So they leave a square root, a fraction inside a square root. I would say normally does not happen. We don't consider a fraction inside a square root to be simplified, but at least that's what the book says. We'll keep it as that. We're good. As not to confuse you. Okay, we're good there with that. Jamming in 37. Y is equal to 2 cosine squared x over 2. We were trying to graph this, so we're graphing it from 0 to 4 pi. Right there. Okay, so thinking to myself, well, there has to be some kind of formula. That is, they're testing me on something over here. Cosine a over 2 is equal to plus or minus the square root of 1 plus cosine of a over 2. I guess that's the formula I'm thinking about. And let me switch colors actually, I can see. All right, this guy has a square inside it, so I'm assuming this is what's going to happen here, where I'm going to have to square both sides. With the squaring of both sides, I get my square like I wanted it. This one, the plus and minus disappear, the square root disappears with the square. So I got 1 plus cosine a over 2 as far as formula goes. Oh, easy. Okay, this is good. It's 2. So all I'm going to do is replace the a with an x, okay, as the variable. So based upon formula, this guy becomes 1 plus cosine of x over 2. The 2's cancel, and what I'm really graphing is 1 plus cosine x at the end of it all. Love it when it turns out to be so easy. So this is 2 pi, half of that, and half of that. Let's see, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, which is 3 pi. 5 pi over 2, 6 pi over 2, 7 pi over 2. I think I got everything I need there. So this is cosine. I know cosine. Cosine starts high in and then comes back up, except I've translated this guy 1 unit higher as well. So instead of starting at 1 going to -1, now I start off at 2 and I really just go to 0. So how about here? Comes down to here, hits 0 right there, comes back up, and then does the same thing. Hits here and comes back up. Voila. Are we good there with 37? All right, jamming. Are we good? All right. That'll be just enough time to do the rest. Okay, so let's go back to our little formulas that we've made. And we created every single one of them last time here. So maybe that took a little too long here. So we're just going to do one of them today here. So this is called the product of sum formulas. Notice it's a multiplication between the two. And what you do is you make it so it's just an addition between the two. So we want to go the other way today, and then we'll deal with the examples from the textbook as well. So first things first, if you have your notes out from last time here, if you would just want to label 1, 2, 3, 4, that's the way the book does it. It labels these guys as one, especially for the homework. Verify this formula or verify this formula. And I even Googled it this weekend. I'm thinking, is there any application questions to product to sum formulas from trigonometry? Did not get a single thing. So,
Wait,
I was
so does, like, because mine are in a different order than that, so should we label it how you label it, or just label it 1, 2, 3?
you can label the way I labeled it as, did we derive them in a different way?
Well, 1 and 3 and then 2 and 4. Yeah.
Okay, gotcha. You see the subtraction symbol. That's right, because we added both on it. Okay. So here's our issue here. We're going to go the other way. So I want this little a plus b to be a single angle, and I want a minus b to be a single angle. It has to be like something here, something there. Those two are different from each other, first of all. Now let's see how far we get. Sorry, I've got some people writing them down right now, so I'll wait just a bit here. Go for it. Again, because this is for you guys, not for me. I should have subtracted last time. Lots of writing on these, huh? I hate formulas, they're like so super long. But it is what it is. All right, and then you guys remember last time? Remember for, notice just on the formulas, notice the first angle is always a plus b, second angle is a minus b. We go all the way down except for this last one here. Remember last time we had to switch them around because the negative was there. So let's see what we'll have to do with this one. Let's just derive the first one. So we'll derive the first one, then we're just going to write down the second ones, the other three from the textbook here. So we're going to take this guy right here, boom, and I'm going to rewrite it just real quick here. These get called the sum to product formula. So it's going the other way. And so let me rewrite the first one the way it is. It's the sine of A cosine B equal to 1/2, and just rewriting it all over again. Sine of A plus B plus sine of A minus B. Okay, we're good there. Since I'm trying to solve for the other side, let's multiply by 2. At least I'll get that way. Let me get multiplying both sides by 2. And if you want to just write down this one instead, that's fine. And here's where we get stuck. Because eventually the A minus B has to go away and the A plus B goes away.
Mr. Benji,
Yes, go ahead.
what's the difference between number 1 and number 2? Because aren't like A value and B value are interchangeable? So like it's sine A times cosine B, but the one below it is cosine A times sine B. So if you have a problem that's cosine times sine with just 2 different values, can't you use either one?
Yeah, except for the angle values are different. So cosine, it's cosine of A here. and then it's cosine of b. The only time they would be the same if they were both 45 degrees.
So do you only ever use those two in relation to each other? Because if you have just like a problem that's just like cosine of 35 degrees and sine of 50 degrees, couldn't you just choose either one? Or would it only be used in a context where they give you A is this, B is this?
Yeah, on the
Okay.
homework, that's what they do. Yeah. Derive the formula if A is this and B is this. Cool. Good question. Cool. We are here. So the trick is, what's the trick? Mathematics always likes a little trick here. So if this guy has to be one single value, this has to be one single value. Let's just name a variable. And we're going to call alpha. We're going to use the Greek letter here as not to get confused here. So okay, that's fine. Let's make one angle out of it. So angle alpha is A plus B. And then we have beta. We're going to call it A minus B. So we're just going to label, and beta is written kind of funny. It's not like a B. It has this little extra little bar that goes beyond the B, just a little lower. And I figure we'll just do exactly what we did here. Let's do this here. Let's add these guys together. So alpha plus beta. And almost by magic or by mathematics, almost exactly what we wanted here. The B's are going to cancel, is that right? I'm left with 2A. And voila, how about we divide both sides by 2? And that's cool, because you know what? That's beta there. That means that A there is equal to this little sine of A over here. I can replace that sine of A with what I want. That's cool. My only problem is, so this guy got replaced right here. This is alpha plus beta divided by 2. And now I have this to be alpha now, is that right? I need to replace this guy. What should I do to replace B? How do I get B out of this whole thing here? I would go with that. Corinna says subtract. Everybody agreed there? If I B subtract a negative B, it'll give me what I want. So let's do that. On the next slide, let's do the same setup as we had before. And this time, sorry, I'm going to go a little fast here. Sorry. Alpha, same thing. Beta, the same thing here, but let's subtract. Alpha minus beta this time. And then I had to do it off to the side because I had to sort of see what's going to happen. This is really A plus B subtracting A minus B. And if I take the parentheses off of this guy here, this will just be A plus B still, but this is going to be minus A plus B. Everybody agreed? That's cool. A's are gone as planned, and I got myself my B value almost. Love it. Again, totally theoretical. If you love this stuff, you should go into theoretical physics or something like that. Divide by 2, and I got myself what I want, and I got my B value. Yeah. Theory is like moving around variables anyways here all the time. Okay, I think we got what we needed here. Let's see, can we rewrite that first equation there? And let's plug in values the way we know them here. So let's see if this makes sense here. I'm going to rearrange so the 2 still there as before. The A that we had before now becomes alpha plus beta divided by 2. So I'm going back real quickly here. I'm rewriting this little guy right here. What we started with, this guy gets replaced by alpha plus beta divided by 2. This guy is alpha minus beta divided by 2. And then this one's just going to be alpha. This one's going to be just beta. Okay. Just moving around our variables. And voila, I get what I wanted. And I really just changed up my variables here. It's almost like, remember in algebra, we like solve for x or solve for y. That's kind of what we just did here. We just moved it around so it's the other way, showing the other way. All right, let's do this. And then the way it's written in the textbook, again, sorry guys, that it's like you're just moving things around here. So first formula, here it is. We switch it around. That's the way the book writes it here. It's going to be sine of alpha plus sine of beta equals, and then we just switch everything to the other side. That's the way the book has it written. That's the way it's used in the textbook as far as formula goes. All right, if we were to derive the other formulas, so I'm not going to make us do that. But this one's kind of too boring. I like derived formulas, but not this one. So I did do the work for you guys. So the second formula derived is this right here. It's the subtraction formula. So it's formula number 2, taken exactly the way it is. You, again, do the exact same process. Alpha is equal to this, beta is equal to this, and you switch the variables around. And the next one. And then we have a fourth formula as well. So here's 1, 2, 3. Last year, when there was no COVID, I did have the students pair up. Groups of 4, whoever did it fast, got some stuff. Can't pair up nowadays, that's no fun. Say again?
Back in legal people.
There you go. BC, before COVID. Okay, then we have the unusual formula. Remember that one, the last one that we did? It had to switch things around because of the negative sign in it. And so the negative sign shows forth now here. So if you guys want to label these here, these are called the sum to product formula. Sometimes called the sum formulas. If you want to label them 1, 2, 3, I'll put them in order this time. And one last one. You guys tell me when you're done or if you need more time.
Okay, so these are called the sum to product formulas.
Mm-hmm. Yeah. So on, if you want to see all the formulas from chapter 5, which I thought that was kind of cool, they just set it all on a single or 2 pages. 294, 295 has all the identities. Really, actually, all the identities that we've covered so far in the textbook, because 5.1 was those basic identities. So 294, page 294, 295, good page number to sort of look at. And they have examples on the side as well, so that's kind of cool. Okay, one last one, writing down, then we'll actually do some work. Formula number 4 is this one here. It has a little -2 in it because of the subtraction that happens. Bless you. stay here because of that. Okay, number full. Cool. All right. Finally, let's get to what we want to get to here. So example 3. Stand up and walk around for a little bit. Verify product formula number 3. And that's the way it's listed. I mean,
Okay.
it's actually going to list the A, list the B value. We do get some identities out of this stuff as well, so we'll do some of those, but really it's just verifying the formula. No application to this stuff, just does it work. And really you're just, since it says verify, you're just making sure the right-hand side and left-hand side equal to each other. That's really all that we're doing. So let me write down the formula again. I have to write down the formula again. So formula number 3, or the product formula number 3, is cosine of A times cosine of B. That one is we have the 1/2. We're adding the cosines.
Oh, wait, so the ones we just did are the sum formulas?
We just did the sum formulas. Product formulas are the ones we did on Friday. An example I did take out of the book. Okay, so it's the same. I have to move back to them. Rarely I do it, but I thought it would be good for this one. So let's go for it. Just plug stuff in as we go. So this is cosine 30 degrees. This would be cosine of 120 degrees. You're going to multiply those guys together. What do we get from? On the left side, on the right side, we are going to take 1/2 of adding them together. So 130 plus 120, you have a 150. And then we have ourselves 30 minus 120. Go with the negative 9 here, we go. All right, let's see. All right, anybody give me cosine 30 degrees?
Or was it square root 3 over 2?
Square root of 2? I agree here. 30 degrees, you go up just a little bit here, off of the x-axis here. Cosine of 120.
Same thing.
It would be 150, because that 150 would be root 3 over 2.
Oh, yeah, you're right. It's negative 1/2.
Not again, Grant.
Yeah, it's the same thing. It's because when it's on the other side, it's like up this way, so left to right is reverse.
I can't say anything because I thought cosine of 30 degrees was 1/2.
Let's go with it here. We go unit circle.
Yes.
Really quick. So I have freeze was easy. It goes off like this. It's the big triangle. So you have, this is the long side, 120. We are here, right? This is the short side now, and it's going to be, I think, a -1/2. What do you guys think? -1/2, maybe? It's the, well, there. Okay, I'm gonna go with the -1/2 on that. 1/2, cosine of 150. It was negative square root. It's almost at 180, right? So that means the x is the longer side. It is on the left side of the y-axis, so negative square root of 2. And then cosine of -190, oh, it's -90.
It's zero.
Zero?
It's 0, absolutely.
Yeah.
And multiplying that stuff together, again, we're just verifying, right? Multiplying that stuff together, do we get the same thing on both sides? Absolutely here, and then we scroll up like this here. And it'll go like this, one side and then the other.
And then do you write QED?
QED would be just fine, question, the little check mark just fine, or the box, whatever your preference is.
This makes my homework make so much more sense.
The squares are going to be the.
Is they're like asking us to plug in crazy things. We're like,
Okay.
Check mark, no, check mark.
if you say so.
Are we good there? We're just verifying it, that's all.
I know.
Okay. Let's jump to this one here. So this one, you have to figure out which one you want to use. So write this as a sum or a difference.
That's a lot of numbers.
Instead of
Actually, no, just two.
three numbers.
Oh, yep.
Four count example.
Three numbers too much.
I'm concerned about the letters in here. I don't like those.
So we're gonna write it as a sum or difference, depending which formula we're gonna use, or we're gonna use a cosine and then the sine formula.
This is where Brenna and I bow out. Like, this is probably where he was talking.
So go back in your notes all the way from what we do to the first slide of today, or from Friday. Which formula, 1, 2, or 3? I'm sorry, 1, 2, 3, or 4?
Two.
It's formula 2. Just because you have a little cosine and this is sine afterwards. Notice the angles are different from each other. And so in this case, it's going to be 10 times. So let me rewrite the, you don't need to rewrite, let me rewrite it just so it makes sense here. So this is right here. That's what I'm starting off with. The formula that I want, don't need to write down the formula, I just want to show you. It's the cosine A sine B formula. It is formula number 2. And the formula says this. So let's just plug in the values that we know. So in this case, A is equal to 5x. B is equal to 3x. And notice it does say verify. You're not trying to get one side to equal to the other. It says just to rewrite it in terms of the other formula. So in this case, is probably the only thing you probably should write down on a sheet of paper is 10 on the outside. This is going to be 1/2 of sine of the first angle plus the second angle minus the sine angle of first angle subtract second angle. Then I'm missing a parenthesis on the other side, huh? It's going to be an extra parenthesis on that over there.
And that's it?
And then simplify. So final answer, how about 1/2 of 10 is 5? I got sine of 8x minus sine of 2x. There should be the final answer.
Minus the 5.
So for
times
these ones,
everything, no. Like the 5 is times both factors, right? So this is just times sine.
That is so cool.
That's
That
right.
is so true.
Crazy. Well, that's what it says here. So.
So let me fix all my mistakes here as I'm doing it too early in the morning. So there should be an extra parenthesis right here. Boom. Maybe.
yeah, I was getting my homework graded at like 1.
Like, yeah, I was
was
like, what's happening?
So how about like that, or you do right there? So you need the extra little parenthesis right there in order to.
I will not lie, changing the slides from distance is extremely cool.
It's pretty cool.
Ooh, thank you. I can keep tabs on Nicholas in the back. That's why I'd rather put it just for
That's
that.
really the problem.
Yeah.
He is the
Keeping us
problem.
from getting work
He's
done.
just constantly causing problems.
Yes. Okay, we're good there. The extra parentheses need to be there. Except if you do them ahead of time and then you make mistakes, that's the problem. Okay, and last one. Can't do that. No, that's no fun. Can't give you the answer. Then when you don't even animate them, that's even a better problem.
No, it's, yeah.
See, then you-
That's
but
like
that's
a
no
small
fun,
piece of it.
because then this is.
The answer is the worst.
It sucks because the answer is literally the word.
Yeah, it's all of it.
Uh-huh.
You can't even like, yeah.
I gotta go animate it then real quickly here.
Oh, God.
For you guys, just for you guys.
He's like, sure, I'll give you the answer.
No.
How about this one I won't animate? Just one page of anxiety for Grant.
I like
All right, this one, again, same thing that we did for example 3, we're gonna verify the sum formula instead of the product formula. So again, right side has to equal left side, just to prove that it works. And this time it can't be A and B, it has to be alpha plus beta, right? Or alpha and beta.
Why did we use the, I don't know, it just feels like it just got way more complicated when we were like doing the formulas and we used those instead of numbers.
Instead of like A and B, or
Yeah.
make C and D or something like that.
Yeah.
It's theoretical, so it's supposed to be. Your dog, I
Like,
heard
you
like
understand
your-
English letters, but you know what you don't understand? Greek. So
Greek.
that's what we're gonna include.
Throw them off, yeah.
Your dog, I heard you like variables. I'm gonna give you variables inside your variables. Yeah, it's only we have like 24 more English letters to choose from.
Not at all.
Yeah, I'm not sure why they don't do C and D, because I know that, whenever we write the angle, right, we write theta, right, which is already a Greek letter. So why do you use alpha plus
Always
beta?
represent A plus B, it does make sense that it's not also in English, because it just seems like it's on the same level.
Yeah,
Yeah, exactly. It's like a different inception.
Like, I kind of get it,
It's not
but
on the
I'm
same
still
level
mad
because
about
it's not
it.
an-
Yeah.
Yeah, I get it
I
too.
guess they could have
but it
used C and D or
offends
something.
me.
Yeah.
It offends me deeply.
So,
Trying to make.
You understand why they
Yeah.
use English, but there's gotta be something better than Greek.
Exactly. Show them all the way to Greek.
so don't need to write down the formula again, don't do that, but let's plug in the values though. Yes. Unless you did already. So cosine of 30 degrees plus cosine of 90 degrees, whatever that should be, it will be the equivalent of 2 times, adding them together, divide by 2. So 30 plus 90, if you want to do that work already, it'll be, and then you're going to do the subtraction between them and then divide by 2 as well. Got lazy, I did not include the degree values anymore. Sorry, Adrian.
relative, so the right side is just in radians.
Or lazy degrees.
It would be very fun and spicy if we just changed it to radians in the middle of the problem for
Fun and spicy is a word to describe
It's
that.
actually
You're
two
right.
words.
You're right, such a crime.
That's actually the best description ever.
Okay, we're good with that. Let's see, that simplifies that. So then really cosine of 30 plus cosine 90 will be the same thing as the multiplication of
Why?
cosine of 60 and negative 30.
Okay, but
Again.
negative. Why does that work?
The negative 30?
Yeah, because would that be negative square root 3/2?
Could be. Or it could be in quadrant 4, which is still make it a positive square root 3/2. So we're quadrant 4.
But wait, so 30 degrees is in quadrant 1.
Uh-huh.
So why would negative 30 degrees even be in existence?
You like went the other way. It's stupid.
Wait, you can go the other way?
Yeah.
Oh, I forgot about that.
We are just in more than halfway through trigonometry.
We're going all the way around.
Oh, Maya, I'm so glad we figured that one out right now.
We've never used it before, and so I just
Never?
stored it away in like back knowledge.
Uh-huh.
We used it like once.
Yeah, we used it once for a very specific
Yeah,
thing.
so I like trash compacted and injected it.
It's back in my memory. My brain just didn't pull it to the front because we haven't used it.
Gotcha. Grant, are we okay?
Yeah.
Brandon, do you have something you want to share with the group?
My unit circles you on. Guys, it wasn't me, it was the unit circle.
Like the stars weren't in alignment. My unit circle was off.
Oh, no, I wrote down the wrong thing.
Okay.
Yeah, my unit circle is right.
Gotcha.
No,
Becomes
teacher, I got the problem wrong with my unit circle.
All right, are we good? So verification, the formulas do work. They're all theoretical, but they do work. And then one last one here with what, 2.5 minutes left here. We got to go with verifying of. Now we get to go into more identities.
Would have been so cool if we spent the last 3 days learning something that didn't work.
That would be so fun.
The history of
Very fun and spicy.
failure. The history of failure around the world. Great elective, but like no one would take it. That would be great elective and like one person would take it. Like the failure.
Zachary would take it.
It would be Zachary and Katie.
Theories that don't work.
Yeah.
Problems that will do nothing for you
Actually,
in
it probably
any.
wouldn't even be Sadie, it would be just Zachary.
Maybe would be annoyed that they don't work, Zachary, and be like,
Exactly,
it's so
exactly.
beautiful.
It doesn't work.
So let's go with it here. Let's see, tangent is probably the easiest one to change into. And notice you have all the 3x and the x. So I think we're gonna have to reduce those somehow. But tangent is gonna be just negative sine over cosine. That's easy enough to do. And then the question is, how do I simplify that right there? So I go, it looks like it's gonna be what, sum to product or product to sum? Which one do I want to use?
Yeah.
So notice on this one here, you only have one value, right? There's no subtraction, right? There's no addition. There's not two values here. You have two terms here. So somehow we got to figure out how to make it back into a single term. That's kind of what we're looking at.
I don't know. Sum to product.
Sum to product, it looks like that to me, yeah. And hopefully some of it cancels. And so now the question is, which one has a cosine and a cosine in it? Cosine subtract cosine. It's number 4. Number 4 would work. If you look at number 4, the last one there, that'll be a -2. and it's going to be, let's see, it's going to be sine of the addition of those two divided by 2. So it'd be 3x plus x divided by 2 multiplied by the sine of the subtraction of the 2 divided by 2. Good there?
Wait,
So it's, you're just trying to line up the correct formula.
Wait, so can we just put sine 2x and sine x?
No, there's no simplify.
Yeah, you can put in 2x in here.
Okay.
Absolutely, yeah. You can put in 2x, that's the next line that I have. Or as you keep it there, one of them's gonna cancel anyways here. So then I need a formula for sine plus sine. First, second, third, or fourth.
Yeah.
Good. Now Adrian's making up his own formulas. That's when we get
I
scared.
mean, the textbook decides that it wants to go to 8.
Yeah, I did like the textbook there.
Can you make a profit for the textbook?
Yeah.
Communicating what's not real.
I am the speaker of the law, the law is the textbook.
Maybe verify on Twitter, but I verified in the
All right, so we have ourselves something that we need to get. Oh, the first sine, sine of 2x or 3x plus x divided by 2. I think I have a something I can cancel right there. So these guys will cancel. Love it. However way you wrote it, the 2's will cancel as well. So I think
Oh
I have
my
exactly what I
goodness.
want. Negative sine x over cosine x, which is what is the on the other side. To the chagrin of Zachary, it does work.
I'll have to tell him. Yeah, it just isn't his style. I'll be sorely disappointed.
Okay, with that, we'll finish up. So thank you so much. Let's see. Wednesday, we're going to finish up 5.5 homework. If you have any questions, look at the challenge questions as well. And just go over any homework that you guys have. And maybe a review.
Wait, so the 5.4 is due today, 5.5 is due tomorrow?
Wednesday, as we go over the homework itself.
Or they don't have any use.
Well, I could use Wikipedia.
That's an incredible idea.
And teach an entire course based on a Wikipedia page.